This time we are going to see a three-step procedure to find solutions of a system of equations ax is equal to b. The first step is to use the elimination process to simplify ax is equal to b as much as possible. We already did that before, so you get this. From the different perspective, this system of equations corresponds to a linear combination of columns, giving me this b prime vector here. We already have seen that if there is a solution to this system, then b prime must belong to the column space of this matrix, which means, in turn, that b prime must be written as some combination of a basis for the column space. But what is the basis for the column space? The basis for the column space is given by this column and this column, because these are the independent columns. The others do not add anything. This implies, essentially, that I can set the three variables y and w to 0 and just find xp and yp, the particular solutions. So the first step is to find a particular x and z that constructs b prime. So let's, looking at the columns, it's quite easy to see, because if I choose x is equal to 1 and z is equal to 0, well, I get 1, 0, 0, and this is 0. Well, that is equal to 1, 0, 0. So we have a solution. So a particular solution xp, the vector xp, must be 1, 0, 0, and 0. The second step is to find the null space of the matrix. We already did this before, and through elimination arrived at this system here, and we found two columns. So all these linear combinations correspond to the null space of A. The third step is just to combine the particular solution that we found and the null space. I draw here a diagram to show the idea. So the complete solution to ax is equal to b has this form, so the particular solution plus the null space. So we started with ax is equal to b, our original system of equations. We used the elimination and arrived at a simplified system where it was easy to find by looking at the pivot columns. It was easy to find a way to use them to create the b prime, and that list of coefficients was the entries of xp, here xp vector. Well, this is the particular solution, 1, 0, 0. Well, in step 2, well, we found the null space, so we set b is equal to 0, and we try to solve this system here. Through elimination, we arrive at a prime xn is equal to 0. A prime is the most simplified matrix possible. And finally, looking by isolating each one of the dependent columns, use the pivot columns to cancel it. We did this 2 times, and we arrived at 2 columns here of coefficients. Well, those constitute the null space, as a and b ranges on all reals. And finally, the final answer to the problem ax is equal to b is written here, the general solution. But notice, why did this 3-step procedure work? Notice, if I multiply a by this x, I have a times x particular plus xn. Using the distributive, I have a times xp plus a xn, meaning a times this plus a times that. But a times this gives me the b, but a times any vector of the null space is 0, and b plus 0 is b again. So ax is equal to b for every x of this form that we found here. That's it.